So let's just see in general what we can say for a cubic polynomial, that if alpha, beta, gamma are the zeros of the cubic polynomial ax cube plus bx square plus of cx plus of d, then what we can say? We can say that the sum of the zeros is alpha plus beta plus gamma, which can be expressed as minus of b by a. Further, the sum and the product of the zeros taken two at a time, that is alpha into beta plus beta into gamma plus gamma into alpha, can be expressed as c by a. And further, the last one, the product of the zeros, that is alpha, beta and gamma, can be expressed as nothing but minus of d by a. So this is nothing but the relationship between the zeros and the coefficients of a cubic polynomial. So always remember these three results, because these are really helpful in order to find out the relationship between the zeros and the coefficients of a cubic polynomial. So now let's just move on further and let's just talk about some of the problems that are related with it. So sums based on relationship. Question number 1 says verify that 3 minus 1 minus 1 by 3 are the zeros of the cubic polynomial this, and then verify that the relation between the zeros and the coefficient, or verify the relationship between the zeros and the coefficient, not that relationship. Verify the relationship between the zeros and the coefficient. Now let's just start first of all with verifying whether these are the zeros of the cubic polynomial or not. So let's just start with the solution set for the very first part. That is, we have to verify whether these three are the zeros of the cubic polynomial this or not. So let's just start with x is equal to 3. So I'm taking x is equal to 3 first. Let's just take x is equal to 3 and substitute it into the polynomial. The polynomial is of the type px is equal to 3x cube minus 5x square minus of 11x minus of 3. Substitute x is equal to minus 3 over here. So it is p minus of 3, which is equal to 3 minus 3 whole cube minus 5 minus 3 whole square. It is x is equal to 3, not minus 3. So it is plus, it is plus, it is plus. Further we have minus of 11 and it is whole square. It is 3 cube minus 5 3 whole square minus 11 into 3 minus of 3. Now let's just solve it. It is nothing but 3 into 3 is 9, 9 into 3 is nothing but 27. It is minus of 5 into of 9 minus of 33 minus of 3. Further we can say this is nothing but 81 minus of 45 minus of 33 and 3 is nothing but 36. So this is nothing but 81 again. So 81 minus of 81 is nothing but is equal to 0. Hence it is verified that x is equal to 3 is nothing but the zeros of this cubic polynomial p of x. Now let's just verify for x is equal to minus of 1. So let's just start with x is equal to minus of 1. Let's just substitute it into the polynomial. P of minus 1 is equal to 3 minus 1 whole cube minus 5 minus 1 whole square minus 11 minus 1 minus of 3. So it is nothing but p minus of 1, which is equal to minus 1 whole cube is again minus 1. So it is minus 3 minus 5 minus 1 whole square is positive, minus minus is plus 11 minus of 3. Now let's just take the negative elements first. It is minus 3 minus 5 minus 8 minus 3 is minus 11. So it is minus 11 plus 11, which is equal to 0. Hence again it is verified that this is nothing but the zero of this particular cubic polynomial. Now let's just further talk about x is equal to minus 1 by 3. X is equal to minus 1 by 3. Let's just substitute x is equal to minus 1 by 3 into the cubic polynomial again. So p of minus 1 by 3 is nothing but is equal to 3 of minus 1 by 3 whole cube minus of 5 minus 1 by 3 whole square minus 11 minus 1 by 3 plus it is minus of 3. So this is nothing but minus of 3. Now let's just solve it. It is minus of 3 divided by 3 cube. So 3 into 3 is 9, 9 into 3 is 27. So this is minus 3 by 27 minus 5 divided by 9 plus 11 by 3 minus of 3. Now let's just solve it. As we know, we can cancel 3 and 27 as 3 into 9 is nothing but 27. 3 into 9 is nothing but 27. So we can rewrite into the formation minus 1 by 9 minus 5 by 9 plus of 11 by 3 minus of 3. So let's just take the LCM. As we know, the LCM of 9 and 3 is nothing but 9 again. So it is 9. So we have minus 1 minus 5. We can add them up as minus of 6 plus of 3. It is nothing but plus of 33 minus of 27. Again, minus 27 minus 6 is minus 33. Minus 33 plus 33 is nothing but 0. So it is 0 by 9, and hence we are getting the answer as 0. So at the end, again, x is equal to minus 1 by 3 is the 0 of the cubic polynomial p of x. So hence it is verified that all these three terms, x is equal to 3, minus 1 by 3, they are nothing but the zeros of the cubic polynomial. And again it says, then verify that the relationship, or verify the relationship between the zeros and the coefficient. Now let's suppose we are taking p of x. Let us suppose we are taking the polynomial p of x, which was of the form 3x cube minus 5x square minus 11x minus of 3, and we can express it into the formation of ax cube plus bx square plus of c of x plus of d. Now let's just compare the values. By comparison, we can say a is nothing but 3, b is nothing but minus of 5, c is nothing but minus of 11, d is nothing but minus of 3. We can say these are the coefficients of the variables x with the different degrees. And further, now let's just check or verify the result. First of all, let alpha, beta, gamma be the roots or the zeros of the polynomial p of x. So let us suppose I am taking alpha as nothing but 3 and beta as nothing but minus of 1 and gamma as nothing but minus of 1 by 3. So first of all, we have a sum of the roots. Which is equal to alpha plus beta plus of gamma. Let's just add up three values. It is 3 plus of minus of 1, so it is minus of 1, minus of 1 by 3, so this is 2 minus of 1 by 3. Let's just take the LCM. It is nothing but 3 into 2 is 6, 6 minus 1 by 3, that is 5 by 3, and further we can express it as minus of 5 by 3, which is nothing but of the form minus b by a. Minus of b by a, because value of b is nothing but minus of 5 and value of a is nothing but 3. So hence alpha plus beta plus gamma is equal to minus of b by a. The first relationship is verified. LHS is equal to the RHS. Further move on toward the product. The product taken 3 at a time. Product of the roots is equal to alpha, beta, gamma. So this is 3 into minus of 1 into minus of 1 by 3. 3 and 3 get cancelled with each other. Minus is nothing but plus of 1. It is plus of 1. Further, plus of 1 can be expressed into the formation of minus of 1 by 1. Minus of 1 by 1, or further we can express it into the formation of minus of 3 by 3, which can be expressed as minus 3 is nothing but d, so this is minus d divided by a. What is the value of a? A is nothing but 3, so hence we can write it into the formation of minus d by 3, or further we can say minus d by a. So this is nothing but the relationship that alpha, beta, gamma is actually nothing but is equal to minus of d by a. Now let's just talk about taking the sum and product taken 2 at a time. Sum and product 2 at a time. Let us suppose we are talking about 2 at a time. So this was alpha beta plus beta gamma plus gamma alpha. So alpha into beta, this is nothing but 3 into minus of 1 plus minus 1 into minus 1 by 3 plus of minus 1 by 3 into of 3. Now let's just solve it. It is minus of 3, minus is nothing but plus. So this is plus of 1 by 3, 3 and 3 get cancelled with each other. So this is nothing but minus of 3. Further we will have minus of 3, this is nothing but minus of 1, not 3, sorry, so this is 1. As we can see that after cancelling 3 and 3, we are getting the answer as minus of 1. So this is minus 3 minus 1. So we are getting the answer as minus of 4 plus of 1 by 3. Just take the LCM over here. It is minus of 12 plus of 1 divided by 3. This is nothing but minus 11 by 3. So we can express it into the formation of minus c divided by a. Minus c divided by a. As the value of c is nothing but minus 11 and a is nothing but product is equal to 3. So hence we can express it into the formation of minus of c by a, or let us suppose we can express it into the formation of c by a. Why so? Because minus 11 is actually is equal to c, so this is plus of c by a. So at the end what we are getting alpha beta plus beta gamma plus gamma delta is equal to c by a. Hence all the relations are totally verified, and even the very first part is also verified. So this is all about the sum which is based on the relationship for a cubic polynomial.